Good day everyone, welcome back to the channel. In this lesson, we will unveil one of the most fascinating features of the command line. It's called the I/O redirection. The term I/O refers to the input and output, and this functionality allows you to redirect the input and output of commands to and from files, as well as connect multiple commands together to form robust command pipelines. To demonstrate the power of this feature, we will introduce the following commands. First command that we are going to talk about is cat, or concatenate files, sort, that sorts lines of texts, Uniq, reports or omit repeated lines, Grep, print lines matching a pattern, WC, print new line word and byte counts for each file, head, output the first part of a file, tail, output the last part of a file, and finally T, reads from standard input and writes to standard output. Okay, so let's talk about standard input, output, and error. Throughout our usage of various programs thus far, we have observed that they generate different types of output. This output generally comprises two categories. Firstly, we have the program's results, which refers to the intended data produced by the program. Secondly, we encounter status and error messages that provide information on program's execution. Taking the ls command as an example, we can observe that it presents both its results and error messages directly on the screen. Okay, so guys, the links for these notes are available in the description. Continuing with the Unix principle of everything is a file, programs like ls utilizes a unique file known as standard output, commonly referred to as stdout, to send their results, while their status messages are directed to another file called standard error, or stderr. By default, both standard output and standard error are connected to the screen and aren't saved into a disk file. Furthermore, numerous programs accept input from a component known as standard input, or stdin, which is typically linked to the keyboard by default. I/O redirection empowers us to modify the destinations of output and sources of input. Typically, output is directed to the screen while input originates from the keyboard. However, through I/O redirection, we can alter these default behaviors. Okay, now let's look at redirecting standard output. I/O redirection provides us with the ability to redefine the destination of standard output. To redirect standard output from screen to another file, we employ the this greater than symbol redirection operator followed by the desired file name. This functionality proves useful in scenarios where we wish to store the output of a command in a file. For instance, we can instruct the shell to send the output of the ls command to a file named ls-output.txt instead of displaying it on the screens. Okay, so let's quickly have a look at this command. So what we are going to do is we are going to type ls-l/usr/bin, and we are going to redirect the output. If you guys remember, what this command does is it displays the files within this directory, which is /user/bin, but now we are going to redirect the output of this command to the ls-output.txt. So now when we press enter, whatever the output that was supposed to pop up on the screen is now inside this file called ls-output.txt. Okay, in this case we generated a detailed listing of the /user/bin directory and directed the output to the file named ls-output.txt, as I mentioned. Now let's inspect the output that was redirected by the command. So now what we are going to do is we are going to type ls-output.txt. Okay, so this is the details of that file. Great, now we have a substantial text file. If we examine the contents of the file using the ls command, we can confirm that ls-output.txt file does in fact contain the output of our ls command. So to check if everything that ls command produced is inside the ls-output.txt file, we can use the ls command, and once we press enter, we are going to see the contents of the file, which contains all the details of the file names that was produced by the ls command. Okay, so pressing the Q key on your keyboard will quit the ls command. Now let's repeat our redirection test with a twist. This time we will modify the directory name to one that does not exist. Okay, so now this time let's do ls-l/bin/usr. This directory does not exist, and we are going to pass the contents of this command to the ls-output.txt file and press enter. So now we get the error, ls cannot access /bin/user, no file or directory. Okay, we encountered an error message, which is expected since we specified a non-existent directory /bin/user. However, the error message was displayed on the screen instead of being redirected to the ls-output.txt file. This is because the ls program sends its error messages to standard error stderr, not standard output stdout. As we only redirected standard output and not the standard error, the error message was still displayed on the screen. Now let's examine the contents of our output file. So now if we do ls-l and the name of the file, as you can see now the file is of 0 bytes or 0 kilobytes. So it has no content inside it. And if you want to check the contents of this file, you can use the ls command. And as you can see, there is nothing inside the file. Okay.
Unlock the world of Daisy Ninja puzzle books, where excitement meets brain power. Dive into the mind-bending labyrinths of Maze Mastermind. Conquer the Sudoku challenges in Sudoku Ultimate. Uncover hidden words in Word Search Wizard, and decode mysteries in Word Spy Adventures. Whether you're soaring above the clouds or speeding down the tracks, turn your downtime into brain-boosting fun. Perfect for all ages, these books guarantee hours of entertainment. Daisy Ninja puzzle books, your passport to endless excitement on the go. New release each month.
The file now has a size of 0. This occurred because we used the redirection operator to redirect output. The destination file is always overwritten from the beginning. In this case, since our ls command produced no result except for an error message, the redirection operators started to overwrite the file but stopped due to the encountered error, resulting in the file being truncated. Interestingly, if we ever need to deliberately truncate a file or create a new empty file, we can employ a trick like this. So, for example, if you want to create a new file, you can just say ls-output.txt and it'll create a new empty file. So this could be anything. So let's say we can call it ls-output-2, and it will create a new file called ls-output-2.txt. Okay, by using the redirection operator without any preceding command, we can truncate an existing file or create a new empty file to append redirected output to a file instead of overwriting it from the beginning. We can use the redirection operator, which is the greater than symbol twice. Here's an example. So now let's type ls-l/usr/bin, and we are going to append our content of the ls command to the ls-output file. Okay, so now if you type ls-l and press enter, you can see this file over here is of the size 47,556. Okay, so if we keep repeating this command a couple of times, you will notice, and now if we type the ls-l, you will notice the size of that file has increased. The reason is every time that we applied this command, instead of overwriting this file, it actually appended the result of this command to this file, then this command back to the original, back to the appended file. So the content was from here, then this was added, then this was added. So then the total output is about this much, okay, which is about 4 times the original size. Okay, so by using the direction operator, which is the double greater than operator, the sign, the output will be appended to the file. If the file does not exist, it will be created, similar to how the greater than operator works. Let's test it out as we did here. So over here also you can see the size was much bigger. Okay, so by executing the command multiple times, we appended the output to the file, making it 3 times larger, as I mentioned earlier. Okay, now let's look at redirecting standard error. Okay, to redirect standard error, we need to use the file descriptor number. While we commonly refer to the first 3 file streams as standard input, output, and error, the shell internally uses file descriptors 0, 1, and 2 to represent them respectively. To redirect standard error, which corresponds to file descriptor number 2, we can use the descriptor notion like this. That is ls-l slash bin slash user. It's a directory that does not exist. To the redirection operator, ls-error.txt. It's the new file that we are going to create. Okay, so now the error, which was supposed to be that the directory does not exist, that error has been redirected towards the ls-error.txt. Okay, so to confirm, we can use the list command on the ls-error.txt, and as you can see, the error that was caused is now inside this file. Right, to redirect standard error to a file, we can use the file descriptor 2 right before the redirection operator, as we did. This will redirect any error messages to the file ls-error.txt, as we saw. Okay, now redirecting standard output and standard error to one file. So now what to do when you want to redirect both the standard output and the standard error, the one single file? You do the following. Sometimes we want to gather all the output from a command into one file. To achieve this, we need to redirect both standard output and standard error simultaneously. There are 2 methods for this. The classic approach, compatible with older shell versions, goes like this. That is ls-l slash bin slash user, then the redirection operator, then the file name, and then this additional command, which means standard error and the standard output. Okay, so let's look at the command quickly. So it is ls-l slash bin slash usr, the redirection operator. So we'll name the file ls-output.txt and then 2 and 1. Okay, so if now we look at the directory, oops, I think I made a mistake over there. Rather than 2 dashes, the command must be with a single dash. Okay, so now let's clear the terminal and check out our directory, and as you can see, the ls-output file is there and it is only 56 kilobytes big. Okay, so let's quickly have a look into the file, and we'll use the ls command, and as you can see, no such file or directory error has been redirected to the ls output file. Okay, so with this technique, we execute 2 redirections. Initially, we directed the standard output to the file ls-output.txt, followed by redirecting file descriptor 2, which is standard error, to the file descriptor 1, standard output, using the syntax 2, then the greater than symbol, and 1. Okay, it's crucial to consider the sequence of redirection. Redirecting standard error must follow the redirection of the standard output or it won't function properly. In the given example, ls-output.txt 2 greater than and 1 directs the standard error to the file ls-output.txt. However, altering the order to 2 greater than and 1, then to redirect it to the ls-output.txt will send standard error output to the screen. Okay, so newer iterations of bash offers an alternative, it's more efficient approach for executing this combined redirection. So let's look at the new way the bash does it. So the command is ls-l/bin/usr, and we'll just type and then the greater than symbol and the ls-output.txt. Okay, so now let's look into the file ls-output.txt, and you can see the error message has been sent to the file. Here we employ the single notion and the greater than symbol to redirect both standard output and standard error to the file ls-output.txt. You can also append the streams of standard output and standard error to a single file as follows. To do that, all you need to do is add another greater than symbol over here, and if you keep applying this command multiple times, so we'll see the no such directory error however many times. It's 6 times. Okay, so let's look at the ls-output file, and as you can see that no such file or directory error is now 6 times inside this file because we have appended the generated messages or errors to the file called ls-output.txt. all right, so getting rid of unnecessary output. Occasionally we prefer silence over output when executing a command, especially for error and standard messages. The system offers a method for achieving this by redirecting output to a unique file named /dev/null. This file serves as a system device called a bit bucket, essentially discarding any input it receives. To mute errors from a command, follow the following steps. So to achieve that, we'll say ls-l/bin/usr2 and the redirection symbol, then /dev/. That's all you have to do to achieve that. So remember, dev/null in Unix culture, the concept of the bit bucket originates from Unix early days and has pervaded various aspects of Unix culture due to its widespread use. When someone mentions sending your comments to /dev/null, it refers to discarding them. For further illustration, refer to Wikipedia article on /dev/null. All right. So now let's talk about redirecting standard input. So far, we haven't come across any commands utilizing standard input, though truthfully we have, but we'll unveil that surprise shortly, prompting the need to introduce one now. So for that, we'll use the cat or concatenate file command. The cat command reads one or multiple files and duplicates their contents to standard input, demonstrated as follows: the cat command, then the name of the file. In many instances, we can equate cat to the type command in DOS. It allows you to view files without pagination, such as cat ls-output.txt. So let's check out this command, cat ls-output.txt. Okay, so this is the content of the ls-output file. All right, so this command will show what's inside the file ls-output.txt. Cat is commonly used for viewing concise text files because cat can take multiple files as input. It's also handy for merging files. Imagine we have downloaded a large file split into several parts, commonly in Usenet for multimedia files. Let's assume the files were named movie.mpeg.001, movie.mpeg.002, so on till movie.mpeg.099. We could join them back together with this command. So what we'll say cat movie.mpeg.0*. By using star, that means we are using a pattern combination. So what we're saying is any file that starts with movie.mpeg.0 and the star means anything after that. It could be anything. It could be an alphabet or a number or however, and the length could be of any. Take all those files and merge them together. The contents of those files, merge them together into a new file called movie.mpeg. Okay, because wildcards consistently expand in a sorted manner, the arguments will automatically arrange themselves in the correct order. Right, That's all good, but how does this relate to standard input? Not much at this point. Let's explore further. What occurs if we input cat without any arguments? So let's check it out. Nothing. Nothing seems to occur. It simply remains idle, appearing as if it's frozen. However, despite this appearance, it's actually functioning precisely as intended. All right. When cat lacks arguments, it reads from standard input, which by default is linked to the keyboard, waiting for our input. Let's add the text below and press the enter key. So we can just copy this text over here, paste it here, and then we press the enter. And what it has done is it has displayed the content that we entered from the standard input and it displayed that content back to us. Okay. So afterwards, input a control D, meaning hold the control key and press D to signal to cat that it has reached the end of the file, or EOF as standard input. So now if we do control D, it will end the cat command. All right. So this is how our output looks like. So when lacking file name arguments, cat duplicates the standard input to standard output, resulting in the repetition of our entered text. This functionality allows us to craft brief text files. Suppose we aim to generate a file name lazy_dog.txt with the example text. To achieve this, we would execute the following command. So let's quickly create a text file using the cat command, and the name of the file is lazydog.txt. Now when we press the enter key, the cat command will wait for the standard input, which is the keyboard input, and once it has received the input, it will take that input and put it inside the lazydog.txt. Okay, so now let's paste the same text. Once we have done that, we will press the control D. Okay, so now let's look at the lazy dog text file, and as you can see, the quick brown box jumped over the lazy dog. Text has been added to the lazydog.txt file. All right, enter the command and input the text you wish to place in the file. Don't forget to conclude with control D. As we did using the command line, we have essentially created the simplest word processor. To review our work, we can utilize the cat to duplicate the file content to the standard output once. We use the less command, but you can use the cat command also, obviously, because we are talking about cat commands. Let's use that, and the content of that file is now displayed to the standard output. Okay, having grasped how cat handles standard input along with file name arguments, let's experiment with redirecting standard input. Okay, so now this time we'll utilize this command and we'll say this. So through the use of the less than redirection operator, we alter the standard input's origin from the keyboard to the lazy_dog.txt file. The outcome mirrors that of using a single file argument, while not especially advantageous compared to passing a file name argument. This showcases employing a file as the source of standard input. However, other commands leverage standard input more effectively, as we'll soon discover. Before proceeding further, take a look at the cat commands manual page, as it contains several intriguing operations worth exploring. So if you want to check out the manual page of the cat command, you can just say man cat. You will see all the functionalities within the cat command. All right. So now let's talk about pipelines. Commands leverage a shell feature known as pipelines, which harness the ability to read data from standard input and transfer it to standard output. This is accomplished using the pipe operator, or this symbol, vertical bar, allowing the standard output of one command to follow into the standard input of another. So this is what the syntax looks like. So it's command 1, then the pipe symbol, and then the command 2. To illustrate this thoroughly, we'll require several commands. Recall our mention of a command that already accepts standard input. That's less. We can employ less to display page by page the output of any command that directs its result to standard output. So that would be ls-l/usr/bin pipe less. right? So this method is increasingly useful, though this method is incredibly useful. Through this approach, we can conveniently inspect the output of any command that generates standard output. All right, so you can quickly just go through the output as normal, and once you are done, you can just press the Q key and exit out of the file. Okay, so the difference between the greater than and the pipe redirection symbol: initially distinguishing between the redirection executed by the pipeline operator and the redirection operator greater than symbol might seem challenging. In essence, the redirection operator links a command to a file, whereas the pipeline operator connects the output of one command to the input of another command. So command 1 is redirected to file 1, then command 1 is piped to command 2. Many individuals experiment with the following when learning about pipelines: just to observe the output, command 1 redirected to command 2 answer. Sometimes something really bad happens. Here's an real example shared by a reader who was managing a Linux-based server appliance. In their capacity as the super user, they executed the following line of code, which was cd/user/bin ls redirected to less. The initial command led to the directory hosting most programs, while the subsequent command instructed the shell to replace the file less with the output of the ls command. Given that the /user/bin directory already held a file name called less representing the less program, the second command replaced the less program file with the text from the ls command, thereby erasing the less program from the system. That's a really bad situation to be in. Okay, the key lesson is that the redirection operator can quietly create or overwrite files, emphasizing the need for careful consideration and respect when using it. All right, so now let's talk about filters. Pipelines frequently serve for executing intricate operations on data, allow multiple commands to be linked together. Often these commands are termed as filters. Filters take input, modify it in some manner, and produce an output. Let's start with the sort command as the initial filter. Suppose we aim to create a consolidated list of all the executable programs in /bin and /user/bin, sort them and display the result list. So to achieve that, you'll say ls/bin/sr/bin, pipe the result to the sort command, and then pipe the result of that to the less command. So what you'll see is all the files inside the /bin/ and /bin and the /user/bin directories are now merged together, then sorted alphabetically, and then displayed on the standard output. Okay, and now you can just use the up and down arrow key to navigate through the output. Right, pretty handy. Having specified two directories, /bin and /user/bin, the output of the ls command would have comprised two sorted lists, one for each directory. Through the inclusion of sort in our pipeline, we transformed the data to generate a unified sorted list. The Uniq command reports or omits the repeated lines. The Uniq command is frequently paired with sort. Uniq takes a sorted data list from either standard input or single file name argument, refers to the Uniq manual page for specifics, and by default eliminates any duplicate entries. Therefore, to ensure our list remains free of duplicates, that is, any programs with identical names appearing in both /bin/user/bin directories, we'll incorporate the Uniq command into the pipeline that we used earlier. Right, so let's check out the same command, but this time we will remove all the duplicates using the Uniq command, display that to the standard output. All right, so if you remember earlier, we had two files that were named this square bracket, right? And every file is now only once. All the duplicate file names have been removed and only one is being displayed. All right. In this instance, Uniq is employed to eliminate duplicates from the result produced by the sort command. Should we desire to display the list of duplicates, instead we include this -d option with Uniq as demonstrated below. So if you guys are only interested in the duplicates, you can just add the -d option to the Uniq command, and once you press the enter key, these are the files that were duplicated, that had a duplicate name. All right, so let's look at the wc command, which prints line, word, and byte counts. The wc, or the word count command, is utilized to showcase the count of lines, words, and bytes present in the files. For instance, you can say wc ls-output.txt, and it will display the following details, all right, which is the number of lines, number of characters, and the size. Here it displays three figures: lines, words, and bytes. Yeah, so these are the number of lines, these are number of words, and these are the bytes, number of bytes in the file. Okay, within the ls-output.txt file. Similar to our prior commands, when executed without command line arguments, wc considers standard input. The -l option restricts its output solely to line count. Including it within a pipeline proves useful for counting. To ascertain the count of items within our sorted list, we can execute the following command. So we'll say ls/bin/usr/bin, then we'll sort all the output, then we'll remove all the duplicates by using the Uniq command, then we'll say wc/l, and now this is the output. All right, so now let's look at the grep command, which prints line matching a pattern. All right, so the grep is a robust tool employed to locate text patterns within files. Its usage is exemplified below. That is, we use the grep command, then the pattern, and then the files. All right, upon encountering a pattern in the file, grep displays the lines containing that specific pattern. Although grep can handle intricate patterns, let's focus on straightforward text matches for now. We'll delve into more advanced patterns known as regular expressions in a subsequent chapter. All right, so let's look at the most simple way we can use the grep command. So now we'll look into the /bin and the /user/bin directories, sort the content, remove all the duplicates, and then we'll say grep zip. So what it is going to do is it is going to display all the files that contains the name zip within them. All right, so once we press the enter key, these are the files that are displayed on this particular system that contains the name zip within them. All right, so there are a couple of useful options available for grep. That is -i disregards case sensitivity during the search. Typically searches are case sensitive, and -v instructs grep to exclusively display lines that do not match the specified pattern. Now let's look at the head and tail, which is print first or the last part of a file. Occasionally you might not require the entire output of a command. You might only need the initial few lines or the concluding few lines. Head command displays the first 10 lines of a file, while the tail exhibits the last 10 lines of the file. By default, both commands present 10 lines of text, but this can be altered using the -n option. All right, so let's look at this command. We'll say head-n5 ls-output.txt. So what it has done, it has displayed the first 5 lines of the ls-output.txt file. Okay, these can be used in pipelines as well. So you can say ls/user/bin pipe tail-n5. All right, so what it has done, it has only showed the last 5 files from the ls command, which displayed all the files from the /user/bin directory. So the tail command offers an option enabling real-time viewing of files, particularly handy for monitoring the progress of log files during writing. In the upcoming example, we'll observe the messages file within /var/log or the /var/log/syslog file if messages isn't present. Note that accessing this may necessitate super user privileges on certain Linux distributions, as the /var/log/messages file might contain security related data. So now let's utilize the tail command, and we'll say /f/var/log/messages. Okay. So in this particular system, the messages file does not exist, but if it did, you will see an output similar to this. All right. So let's move on. Employing the /f option, tail continuously observes the file, instantly displaying the newly appended lines on the screen. This process persists until you input Control C. Now let's look at the T command, which reads from standard input and output to the standard out and files. In line with our plumbing analogy, Linux offers a command named T, acting as a T fitting on our pipeline. The T program reads standard input, duplicating it to both standard output, enabling the data to proceed through the pipeline and to one or multiple files. This proves beneficial for capturing the content within a pipeline at an intermediate processing stage. Below, we revisit a previous example, this time incorporating T to save the complete directory listing into the file ls.txt before grep filters the pipeline's content. Okay, so we'll say ls/user/bin, then we'll pipe it to T ls.txt, then we'll use the grep function to display the zip files. Okay, so now it has displayed all the files that contain the name zip. But now let's look at the ls.txt file, and as you can see, that file contained all the output, but only the file names that contain the name zip were displayed on the standard output. Okay, all right guys, so summing up, as usual, explore the documentation for each command covered in this chapter. We have only touched upon this fundamental usage, but they boast numerous intriguing options. With more Linux experience, you'll discover the command line's redirection features to be incredibly beneficial for tackling specific issues. Many commands utilizes standard input and output, while nearly all command line programs rely on standard error to showcase their informative messages. Okay guys, so do go through this chapter. The link for this chapter, as mentioned earlier in the video, will be provided in the description. I'll end the video over here, and in the meantime, do practice your Linux commands, and we will see each other in the next video. Take care. Bye bye.